Create an exponential model using x natural log y for the data shown. Okay, so what we're going to do is we're going to see if this data makes a linear model for natural log y. Then we'll use that to go ahead and find the exponential model. So first we're going to have natural log of y. And what I'm going to do is I'm just going to do the natural log calculations on a handheld scientific calculator. I'll just write them down below. So this natural log of 10 is 2.30. Natural log of 31 is 3.43. Natural log of 43 is 3.76. Natural log of 61 is 4.11. Natural log of 90 is 4.50. Natural log of 121 is 4.80. And natural log of 210 is 5.34. So then what I'm going to do is I'm going to enter all this data on the graphing calculator. And then we'll find a linear model. So what I'm going to do is I'm going to do stat and then edit. And then for list 1, those are my inputs. So it's just going to be my x values. So 1, enter, 2, enter, 3, enter, all the way to 7. Then L2, that's going to be my list of outputs for natural log y. So 2.30, 3.43, 3.76, 4.11, 4.50, 4.80, 5.34. Okay, now let's look at the graph. Nothing showing right there, but what I'm going to do is I'm going to go to y equals. I'm going to turn on my stat plot on by moving the up arrow once, then hitting enter and then down. And notice the plot 1 is highlighted. Now let's look at the graph. Okay, so we can see some data points there. And I'm going to change my window. Let's see, first of all, I'll go zoom 6 to make it a standard window. And then I'll adjust the window further. I really need my x min and y min at 0 and not negative 10. So I'm changing both of those. Okay, now you get a good idea. Remember, this is x versus natural log of y, and if we have a linear pattern, it makes a good model for exponential growth. So now what I'm going to do is I'm going to use a calculator to determine the linear model. Here's how you do that. Stat, and then right arrow to calc, and then linear regression, which is number 4. And all those defaults are fine, so I'm just going to go to calculate here. Okay, so here's what the linear model is. It's 0.45x plus 2.23. And what I'm going to do is I'm going to show you how to graph that along with the data points. So y equals, and then I'm going to go to vars, V-A-R-S, and then down to statistics, which is option 5, and then over to equation, and then first one is regression equation, which is what we just calculated. So I can put that regression equation right over the points. Okay, so you can see that a linear model is a good fit here. I mean, it's real close to those points. It does fit the shape. So it would be safe to conclude that the table given did show an exponential model. And what you could do from here if you wanted to is you could actually find that equation. So it was 0.45x plus 2.23. and that's natural log of y. Now what you can do is you can rewrite this in exponential format. So what I'm going to do is I'm going to say natural log of y is the same thing as e to the 0.45x plus 2.23 equals y. And now all I need to do is apply some rules of exponents to rewrite this in a different type of a format, so it's not base e. So first thing I'll do is, I'm actually going to switch. I'm going to put the y over to the left and the e 0.045 x plus 2.23 on the right. Then I'm going to use the property of exponents to split up this power. So I'm going to write it as e to the 0.45x, then times e to the 2.23. Okay, now simplify some more, y equals, and I'm going to convert these e to the whatever power into just simple numbers. So I do e to the 0.45, that's 1.57, let's say. We'll just call it 1.6. So 1.6 to the x, and that'll be times e to the 2.23. So that's 9.299, we'll call it 9.3. Okay, and finally, I'm just going to switch these two terms using the commutative property of multiplication. So it's going to be 9.3, which is the initial amount, and then times 1.6 to the x. So this is our exponential model for the data shown. Okay, one last thing. I want to see how valid that model is. So I'm going to enter in all this information in the calculator and then calculate the exponential model. So I'm just going to type in, instead of my natural log of y, I'm just going to type in the y. So now I'm going to quit out of here, then go to Stat, and then over to Calc, and then I'm going to do exponential regression. And we'll just scroll down, calculate. Okay, so here we have 9.4 for the initial amount and 1.6 for the base. Okay, so this is very close to what we found by calculating the x, ln, y linear model and then converting it to an exponential model. So that hopefully shows you this is a valid technique. Now the whole point of this is to show that you can interpret whether an exponential model is good for a set of data by creating a natural log model and then seeing if it's a linear fit. If you have that linear fit, you know you're justified in creating an exponential model.